Okay, so hopefully you watched my first video on combining like terms. After making that video, I thought, I really needed to do a little bit more advanced stuff here, and so decided to put together a second video on combining like terms. So hopefully you watched the first video. Here you are on video number two. I want to start off by just kind of talking about how we can simplify things. Simplify means to clean up as much as you possibly can. It does not imply that your answer is actually always a number. If I say the word evaluate, then you're going to have an answer that's a number. But when I simplify things, it just means clean it up as much as I can. With this first problem, I have the number 3 plus 5. I hope that we all agree that that is the number 8. And so when I go over here and I do this second problem here, I have 3x plus 5x. Those two terms are going to go together to become an 8x. Likewise, I can put 3x squared and 5x squared, which is going to give me an 8x squared. Or I can put together a 3x to the third and 5x to the third, and that's going to give me 8x to the third. I could even put these together where I have 3 root x plus 5 root x, and that would give me an 8 root x. What I want you to notice about all of these scenarios here is I am just simply counting things. Apples go with apples, and oranges go with oranges. Okay, so for my second example today, I want to talk about a thing that actually happens quite often, and it's not something to freak out about. If I take a look at this example here, I have a bunch of terms that I need to put together. The first thing I want to look at is I've got this 4a squared, and so if I look for another a squared term, you'll notice here that I have a negative 4a squared. And so if I take 4a squared and I subtract 4a squared, those are going to simply cancel and they're all going to go away. I'm not going to write a squared down because actually I have 0 a squares, and so I just don't want to write that down. They simply cancel and they go away. When I look at my second thing, I'm going to see what's left over here. I've got 6a here and 3a here. You're going to have 9a left over. Therefore, in this example, my simplified form of this is just simply 9a. Okay, so I promised you some more complicated things, and here we are right away, just jumping right into it. What I want you to notice first with this example is that it's got a set of parentheses, and this is going to require us to actually use the distributive property. Hopefully you watched my video on the distributive property. I've got that up. So if you haven't, you definitely want to watch that first before you do this. But in this scenario here, I have this set of parentheses, and I need to clean that up, open that set of parentheses up before I can actually do anything. The very first thing I'm going to do is I'm going to go ahead and copy down my 3t here, and then I'm able to distribute my 5. Now this is a positive 5, so when I distribute a positive 5 to a 2t, that's going to give me a positive 10t. Likewise, I'm going to distribute that 5 to that negative 6. Positive 5 times a negative 6 is going to give me a negative 30. Now that I've actually opened up that set of parentheses using the distributive property, I can see actually very clearly what items can actually go together. In this scenario here, I've got a 3t here, can also go with a 10t right here. When I put those two terms together, I'm going to end up with 13t. I'm going to go ahead and cross those off. I like crossing things off, gives me a very, very nice visual. The last thing that you'll notice that I have left over is simply a negative 30 here. I don't have to put it with anything else, so I'm going to just go ahead and copy negative 30. My answer is 13t minus 30. Okay, in this last scenario here, you will notice that I have a set of parentheses in the middle of this expression. And so once again, I want to open this up again. I'm going to begin by just simply copying down the y here. I'm not going to do anything to that, but I am going to distribute here. And you'll notice on this distribution that the number in front there doesn't appear to be 1. There actually is a 1 here. And so I'm going to go ahead and put a 1 here. That means that there's a negative 1, but actually you could go ahead and erase that, and because it's there, but we don't write it. We're kind of lazy, and so it's implied that there's a negative 1 there. So when I distribute this, I'm going to distribute the negative to the 2y. That is technically negative 1 times 2, which is actually going to give me a negative 2y. I'm going to also go ahead and distribute that negative to the negative 8. A negative 1 times a negative 8 is going to give me actually a positive 8. The last thing that I'm going to do is I'm going to go ahead and copy down my plus y at the end. I had a y in front. I also had a y at the end. The last scenario here is I'm going to go ahead and start gathering together my like terms. You'll notice that there is one y here, there is a negative 2y here, and there is one more y at the end. Something unique once again is going to happen here, in which I have y minus 2y, which gives me a negative y, plus one more y is going to give me 0 y's. And so all of the y's actually in this scenario end up canceling out, and the only thing that I'm left here with is a positive 8, and therefore my answer is 8. I hope this video helped you out with combining like terms, and I hope you have a great day.